My name is Devabrata Goswami. When I say that, it becomes clear that I belong to a family of Goswamis and my name is Devabrata. In fact, sometimes names can convey information about a person's village and region as well. But we can decipher this information because certain rules are followed while naming people. Similarly, naming compounds also requires certain rules. What is this system? Let's find out in today's episode. Hello, I am Devabrata Goswami. Welcome to a logical episode of chemistry. Let's take a peek into what I have in store for you today. Today, we are going to talk about the unique properties of carbon, the broad classification of organic compounds, and the IUPAC nomenclature of alkanes. And finally, there is exam Decoded to test your learning. So let's get started. Carbon is present in every living thing. Due to its abundance, it was very important to have a different stream of science dedicated only to carbon, and that is organic chemistry. Carbon is a unique element. It has the ability to bond with itself and form long chains. This is called catenation. Also, carbon shows tetravalency, because of which it can form 4 bonds. This results in the formation of a large number of carbon compounds. So, the branch of chemistry which deals with compounds of carbon with hydrogen, oxygen, nitrogen, sulfur and phosphorus is called organic chemistry. To make it simple, chemists have grouped organic compounds into various classes. Here, we can see the different types of organic compounds. They are divided into 2 main types: acyclic or open chain compounds and cyclic or closed chain compounds. To know more about these 2 types, we have to understand their structures. Acyclic compounds are straight or branched chain compounds. Simply put, they contain straight or branched chains of carbon. They are also called open chain compounds. Cyclic compounds contain carbons which are sometimes attached to other atoms in the form of a ring. These compounds are also called closed chain or ring compounds. But that's not all. Acyclic and cyclic compounds are further divided. Let's begin with cyclic compounds. Cyclic compounds can be further classified as homocyclic and heterocyclic compounds. Let us first study homocyclic compounds. Well, homocyclic compounds are those compounds whose rings are made up of only carbon atoms. That's why they are also called carbocyclic compounds. When the rings of cyclic compounds contain other atoms besides carbon, they are called heterocyclic compounds. Here we have an example of heterocyclic compound called tetrahydrofuran. Note that this compound contains an atom of oxygen as well as carbon atoms. So, it belongs to the class of heterocyclic compounds. Homocyclic or carbocyclic compounds can further be classified into alicyclic or aromatic compounds. Now, what are alicyclic or aromatic compounds? Alicyclic compounds are those cyclic compounds which bear a resemblance to aliphatic compounds in their properties. Examples of alicyclic compounds are cyclopropane and cyclobutane. Aromatic compounds, on the other hand, have delocalized pi electron system. Common examples of this class of compounds are benzene and naphthalene. As we discussed earlier, heterocyclic compounds are those cyclic compounds which contain one or more heteroatom, usually oxygen, nitrogen and sulfur. Here we can see three examples of heterocyclic compounds: furan, pyrrole and thiophene. That was all about the classification of organic compounds. Let's now figure out how they are named. What are the rules with which we can name organic compounds? The International Union of Pure and Applied Chemistry, or IUPAC, has developed some rules for naming organic compounds. This is primarily to ensure that uniformity is maintained in naming organic compounds. Another advantage of this method is that the structure of an organic compound can simply be drawn just by knowing the IUPAC name of the organic compound. Let us begin by naming some simple hydrocarbons. Hydrocarbons can be divided into saturated hydrocarbons and unsaturated hydrocarbons. Hydrocarbons are saturated if carbon-carbon single bonds are present. Such compounds are called alkanes. If there are double or triple bonds, then these compounds are called unsaturated. So let us learn the IUPAC or IUPAC names of alkanes. Straight chain alkanes are named by adding the suffix ane to the word root. The word root is given according to how many carbons are present in the alkane. For example, methane is the name given to that alkane which has one carbon atom. Here, meth is the word root and ane is the suffix. Similarly, ethane has two carbon atoms, and the same follows with propane, butane, pentane. An organic compound can be branched with branches of various groups shooting out from the parent structure. This means that if small chains of carbon atoms are attached to one or more carbon atoms of the parent chain, the compound formed is called a branch chain hydrocarbon. Branch chain hydrocarbons are named by adding the prefix of the alkyl group to the name of parent chain. Like in this example, we can see three methyl groups branching out. Before we move deeper into this topic, let's take a break. But don't stop thinking, because I have a question for you. Name the scientist who coined the word organic chemistry. Keep thinking or log on to www.topperlearning.com for the answer. Or just wait for me to come back. See you in just a bit. Welcome back. I am Deobrata Goswami and you are watching Chemistry 11. Before the break, I had asked you to name the scientist who coined the word organic chemistry. Well, it's Johannes Jacob Berzelius. He was a Swedish chemist who coined the term organic chemistry in 1807. Moving on, what is an alkyl group? Simply put, an alkyl group is the group which has one hydrogen atom less than the corresponding alkane. So how do we name these compounds? Let's start with alkyl groups. Naming an alkyl group is done by substituting ANE in the name of the corresponding alkane with YL. For example, if we remove one hydrogen from methane, the alkyl group which results is known as methyl group. IUPAC or IUPAC has laid down certain rules and guidelines for naming branched hydrocarbons. The first rule: identify the longest continuous chain of carbon atoms in the molecule called parent chain or root of the given compound. The longest chain may or may not be straight, but it must be continuous. Let's look at an example. In the molecule given on your screen, the longest continuous chain consists of 7 carbons in the parent chain. As you can see, there are some carbon atoms which are not included in the parent chain. These are identified as substituents. Here we have 3 such substituents which are methyl groups. In the next step, the numbering should be done in such a way that the carbon atoms containing substituents get the lowest possible numbers. Coming back to our example, here numbering can be done in 2 ways. One from the left end to the right end, and the second one from the right end to the left end. If the numbering is done in the first way, the substituents fall at the positions 2, 6 and 6. While if we do it the other way around, the substituents are numbered as 2, 2 and 6. So the preferred way of numbering is the second way, since it gives lower positions to the substituents. Note that the name of the parent compounds depends on the number of carbon atoms present in the parent chain. Here, the number of carbon atoms in the parent chain is 7. So, the name of the parent compound is heptane, where hept is the word root. After naming the parent chain, we are left with the alkyl group. We already know that alkyl groups are prefixed to the name of the parent alkane. In this example, one methyl group is present at position 6 and 2 methyl groups are present at position 2. According to the rule, if 2 or more identical substituent groups are present, then the numbers are separated by commas. So the positions will be indicated as 2, 2, 6. Since 3 methyl groups are present, we will write it as trimethyl. So, incorporating all the rules, we get the name of the compound as 2,2,6 trimethyl heptane. Easy, isn't it? Let us take another example in which 2 different alkyl groups are present at equivalent positions. In this case, the lower number is given to the alkyl group that comes first in alphabetical order. Here, since ethyl comes before methyl in alphabetical order, so ethyl should come at a lower position. So, the name of the compound is 3-ethyl 4-methyl hexane and not 4-ethyl 3-methyl-hexane. Moving on, when the alkyl group is further branched, it is named as a substituted alkyl group. Therefore, the carbon atoms of the branched alkyl groups are numbered separately in such a way that the carbon atom which is directly attached to the parent chain is given number 1. The rest of the rules remain the same. Here, a branched alkyl group is present at position 4 of the parent chain. This branched alkyl group has the longest chain of 3 carbons along with a methyl substituent at carbon 1. The prefix or name of such a substituent is enclosed in brackets. So the name of the compound is 2,2,7-trimethyl 4 brackets open 1-methyl propyl close brackets nonane. By now, your mind must be buzzing with questions, just like this young caller who has a question.
Hello sir, my name is Saurabh. I want to know what is the alkane with 100 carbons called?
Thank you for the question. Following the rules, an alkane with 100 carbon atoms is called hectane. Well, that's all the theory for today. Now it's time for a break. But stay tuned because coming up next is Exam Decoded. Welcome back. I am Devabroto and today we are talking about organic chemistry. Let's do a quick recap of all that we have learned today. Today we studied that organic compounds can be broadly classified as acyclic or open chain compounds and cyclic or closed chain compounds. Systematic naming of organic compounds is done by IUPAC. The key of nomenclature lies in correctly identifying the longest chain of the carbon atoms in the compound as the parent chain. As we are through with our revision, it's time for Exam Decoded. Welcome to Exam Decoded. Now that we know all this, it's time to put it to the test. Yes, I am referring to the rapid fire section. The rules are the same. I will ask you 5 questions and you will get 5 seconds to answer each. Every correct answer will get you 1 mark and later I will tell you what that means. The first question. What is the suffix in the names of all alkanes? A, ANE, B, ENE, C, YNE, D, ONE. This one is easy. You must know the answer. The answer is A, ANE, that is ane. Next, cyclic compounds containing one or more heteroatoms are A, heterocyclic, B, homocyclic, C, acyclic, D, none of the above. I know you know the answer. It is A, heterocyclic. The third question. If 3 methyl groups are present in the alkane, the prefix used is A, di, B, tri, C, tetra, D, 3. And the answer is B, tri. Next question. Cyclic compounds whose rings are made of only carbon atoms are called carbocyclic compounds. True or false? It's true. Now for the last question. Acyclic compounds are also called aromatic compounds. True or false? If you said false, you are right. Now let's see how you fared. If you got all the answers correct, then you are a high flyer. You are an achiever if you got between 3 to 4, just a bit more preparation and you will be there. But if you got less than 3, then you need to work a bit harder. But don't worry, I and www.topperlearning.com are there to help you. Let's now take a look at the kind of questions asked from this topic. This topic, classification and nomenclature, comes under the unit organic chemistry and has a weightage of 7 marks. So this chapter is critical from exam point of view. The questions asked from this topic can be very short answer type questions for 1 mark and short answer type questions for 2 or 3 marks. These questions usually test your knowledge ability. My professor told me that it's not enough to know something, it's also important to present it properly. So let's take a look at how you should answer the following question in your exams. Write the IUPAC nomenclature of the following compounds. This question can typically come in your exams for 2 marks. This is how you should answer it. For naming the compound, first select the longest chain as shown, which consists of 3 carbon atoms. Numbering either way will put the substituent at position 2. Finally, for naming the compound, first write the position of the 2 substituents separated by commas and place a dash between the position of substituents and name of compound. Thus, name of the compound is 2,2-dimethylpropane. Writing the correct name along with proper commas and dash will get you complete 1 mark. Now for the second compound. Selecting the longest chain and numbering to give the substituents the least position gives the name of the compound as 2,3,7-trimethyldecaine. Writing the correct name will fetch you another 1 mark. I hope you enjoyed today's episode and understood the classification of organic compounds and nomenclature, particularly of alkanes. If you understood the concept well, then try this question. While naming the organic compound, the prefix ACC and TERT are not considered part of the fundamental name. Why? Keep thinking. I will meet you next time with another topic from chemistry.